This is the NEET 2018 question in current electricity. The question says a set of n equal resistors, each of value of resistance R are connected in series to a battery of EMF E and internal resistance R. Let us try to draw a diagram and see what does it says. There is a resistance R, another resistance R, another resistance R. Like that there are n resistors. Each of resistance R are connected in series. They are all connected to a cell of EMF E and that also has internal resistance. Internal resistance behaves like a series resistance. So, I have written this R, but this is actually internal resistance connected this way. Then the current drawn in the circuit is I. I can write an equation for the current in this circuit. Current means, using Ohm's law, V equal to IR. I means total EMF in the circuit by total resistance. There is only one battery, so the total EMF in the circuit is E. Total resistance means this R and up to n resistors are in series. In series resistance is R1 plus R2 plus R3. N identical resistance means NR. And as I told, this internal resistance behaves like a series resistance. So, for all this NR, this R also behaves like a series resistance. Current goes this way. So, NR plus R, that is the current I. So, I can write like E by R of n plus 1, that was given to us in the problem as I. Now, what happened now is, if now the n resistors are connected in parallel to the same battery, current drawn from the battery is 10L. So, this is all when they are connected in series. Let us see the next part now. When the resistors are connected in parallel, when they are all in parallel, I can draw a diagram and show it to you. This is R, this is one more R, this is one more R. Like that there are n resistors. They are all connected in parallel and so on, and that is connected to the same battery. Of course, that has an internal resistance. Internal resistance, as I told, always behaves like a series resistance. This is the equivalent circuit. Now, I can write the current in this equation. I parallel combination is, as they are all identical resistances, are parallel, the equivalent resistance of all this combination becomes watch R parallel equal to R by N. So, I total EMF by total resistance is the same formula. EMF is E, but the resistance is R by N. For that, again this internal resistance behaves like a series resistance. So, R by N, for R by N, this R is a series resistance. So, I can simplify this as E by R plus NR by N. E, that is N into E by R plus NR, that is N into E by R of n plus 1, that is I parallel. But it is given that I parallel value is 10I. So, here I can write 10I. If this is I, this is 10I. We call this as equation number 1 and this as equation number 2. And let us divide that two equations and see what happens, right. Equation number 1 by 2 gives, 1 on the left hand side is I, 2's left hand side is 10I. Right hand side of the first equation is E by R of n plus 1. Right hand of the second side is NE by R of n plus 1 divided by NE of R of n plus 1. So I can rearrange the terms as I and I can be cancelled. 1 by 10 equal to E by R of n plus 1. This is denominator of the denominator goes to the numerator. R of n plus 1 by NE. This will cancel, E also will cancel. So 1 by 10 equal to 1 by n is only remaining. That means n equal to 10. So the number of the resistors connected in series as well as in parallel, that n equal to 10. That's how we have to solve the problem. So to solve this problem, we shall have an understanding of series and parallel grouping of resistors, right? Learn that concept. I have done the video on that even in detail, so that this kind of problems becomes easy for you. That's it. Thank you for watching.